Solving linear equations where the variable has an absolute value. Now, when the variable has an absolute value, that means the solution is plus or minus. So the absolute value of a variable, in this case x, equals plus or minus 7. Now that symbol you see in front of the 7 is plus or minus. As you can see, there's a plus sign on top and a minus sign on the bottom. Might look a little funny, but you're going to start seeing that symbol a lot. Now, let's look at the original equation. If you put -7 substituted in there for x, would that equal 7? Yeah, the absolute value of -7 is 7, and if we put a +7, that would obviously equal 7, so that you can see that the absolute value of x is going to equal plus or minus 7. Now you can think your way through that whole thing and think about the philosophy or whatever, or just remember the rule. When we have a variable in an absolute value brackets, then the solution is going to be plus or minus. But what if we have a mixture? What if we have units and an absolute value of a variable? Well, we're going to just bring the 5 over so that the variable is by itself. Just like that, and the absolute value of x is 3, and the value of x is plus or minus 3. Now, what if the absolute value of x has a coefficient? We have -4 times the absolute value of x equals -20. And what are we going to do with this negative sign here? Well, it's not a problem because it's not in the absolute value brackets. And therefore, we're going to treat it as a normal coefficient and divide it by -4, divide both sides by -4. And the absolute value of x is 5. And the value of x is plus or minus 5. Now let's try a problem that has addition and multiplication issues. 5 times the absolute value of x minus 4 equals 26. And as you know, we're going to deal with the addition first. We have -4, so we're going to add +4 to both sides, and then we're going to bring all that down. And 5 absolute value of x equals 30. Divide both sides by 5. And that gets the absolute value of x alone. And 30 over 5 is 6. And x equals plus or minus 6. Now let's try an equation where within the absolute value brackets we have a variable and a unit. We have the absolute value of 2x minus 1 equals 7. Now, before I go forward, let me warn you a little bit. And you probably figured this out already. Those absolute value bars can often look like 1s, so be real careful with them. And if you're writing them yourselves on paper, it can even get trickier. So make sure that when you write them a little bit bigger than the book does. I always do that so that it's clear that it's absolute values. And you can see that absolute value bar sitting next to that 1 makes it look like 11. So be careful of that. But what are we going to do here? We're going to take everything out of the absolute value bar and turn the other side into plus or minus. Just like that. That's pretty simple, except as you can see, we're going to have to solve for 2 equations. One where the right side equals 7 and one where the right side equals -7. So we're going to have 2 different answers to this, and it's not going to be plus or minus 6 or plus or minus 3. It's going to be something different. Okay, now we have 2 equations. One where the first equation equals +7 and one where the second equation equals -7. and we're going to eliminate the 1 on both of those. And instead of bringing the equation down to this space right here and this space right here, why don't we bring it back up, and -1 and +1 is going to zero that out, and +7 and +1, and that's going to be +8. And down below we have our 1's are going to be eliminated, and we're going to have -7 plus 1. So we're not going to have +8 or -8. We're going to have -6. So you can see that we needed to solve these two equations separately, and we still have a coefficient in front of the x. So we're going to divide everything on the left-hand side and the right-hand side by 2 on the left-hand side and the right-hand side by 2 on the bottom. And on the top, we're going to have x equals 4. And on the bottom, we're going to have x equals -3. Now, why don't we try an equation where we are using all of the processes that we just learned. Okay, and what we're going to try to do here is what we've been doing previously, which is to isolate our absolute value. So let's get rid of the +2 by subtracting -2 from both sides. And that's going to leave us with 0 over here, -20 here. Bring everything else down. And now we have a coefficient in front of the absolute value. And we're going to divide that out on both sides. So now we have the absolute value isolated, and we have -20 over -4 equals +5. And now we're going to remove the absolute value brackets, and that will do what to the 5? That's right, it makes it plus or minus 5. And now we have 2x plus 3 equals plus or minus 5. And we are going to turn that into two equations. 2x plus 3 equals 5, and 2x plus 3 equals -5. I hope that's not too disturbing that they're not one right under the other, but we're going to need a little bit of room. And that's right, to isolate the x in both of these equations, we are going to subtract 3 from both sides in the upper equation and the lower equation. And we're left with +2 in the upper equation and -8 in the lower equation. So we have 2x equals 2, and we have 2x equals -8. We have a coefficient in front of the x, so we need to eliminate that. So we divide everything by 2, and 2 over 2 is going to isolate both of those x's. And the answer on top will be +1, and the answer on the bottom equation will be -4. So the solution to x is 1 and -4. Okay, we have another equation that looks reasonably normal, but it's not. Let's see why it's not. First off, let's eliminate the 7 from both sides, and that leaves us with a 0 here and a -3 here. Let's bring down everything else on the left-hand side. And the absolute value of 2x minus 5 equals -3. Do you see a problem there? Well, the problem is the absolute value can never equal a negative number. That's what we've studied already, is that the absolute value, the answer for the absolute value is always a positive number. So what do? Well, we don't need to do any more work here. X equals empty set. Now you can place there x equals empty set, x equals no solution, or you can put that funny symbol that I've placed there. Now let's look at something where we have absolute value on both sides. That's not as difficult as it looks. Let's bring both of those out of the absolute values and put both of them in parentheses, since there are two terms that a negative sign is going to apply to. We're going to get a little bit confused there if we don't keep that in parentheses. And we're going to put a plus or minus sign in front of both of them since we brought both of them out of the absolute value brackets. Now, you can do both of these equations, or you can just understand that only one of them needs a plus or minus sign, and it doesn't matter which. So we'll leave the plus or minus sign on the right-hand side and take it off the left-hand side. Now, if you want to go through the process of doing 4 equations instead of the 2 that we're going to be doing, you'll see that there's only 2 answers. So just take my word for it. Take the plus or minus sign off of one of those, and it doesn't matter which. And since we had no sign in front of the parentheses here, we're just going to remove the parentheses and do the same thing here. And up here we have a plus, and down here we have the minus. And since we have a plus sign in front of the parentheses, we can remove these parentheses also. Good, we're coming along real nicely, and we still have parentheses here because we have a negative sign outside the parentheses that needs to be distributed. Distributed to what? Distributed to everything inside the parentheses. We had a positive 4x here and a positive 6 here. Now our 4x is negative and our 6 is negative. Remember, distribute that to everything inside the parentheses. And now we have something that's really workable. Now up above, our 4x is bigger than our 2x, so we're going to bring the 2x, we bring the smaller x over. So it's 2x minus 2x and 4x minus 2x. And of course, bring everything else down. And let's isolate our 2x by bringing the 6 over. And let's bring everything down. And boy, that is starting to get messy. So why don't we go sideways with that? And you can see if I move my head that x equals negative 13 over 2. So let's perform the function of the next equation. And as you can see, in this case, 2x is the larger x. No, negative 4x is not larger than 2x. A negative number is always smaller than a positive number. So let's bring the negative 4x over. With the positive 4x, let's bring everything down. And we have 6x minus 7 equals negative 6. Let's eliminate the negative 7 and bring everything down. And we're left with 6x equals positive 1. Let's eliminate the coefficient. And 6 over 6 is 1x. And x equals 1/6. So the solution to our problems is x equals 1/6. So x equals 1/6, and x equals negative 13 over 2, or 13 halves, you might hear sometimes. And that is the solution to this problem. There are 2 solutions to x. And that is how you solve equations with absolute values. You need a little practice on that. Try the homework on page 56.